Alright, good morning everyone. Sorry for a bit of slight delay. Today we're going to talk about how to teach the computers to understand text. So basically we're going to talk about the technologies behind Google, Alexa and Siri. So let me quickly check. And for those of you who are online, a very good morning. And for those of you who are in Malaysia, yep, all good. Today is the first day of the movement control order. So as usual, I hope everyone stay home, stay safe, and yeah, let's use this opportunity to learn something and don't stop your growth. All right. So one thing, right? A lot of time when we think about asking the computers to analyze text document, we will be thinking like, how does it work, right? Computers supposed to be only able to understand numbers, and when we say numbers like 1, 2, 3, 4, 5, and to be exact, computers understand only signals, which are the binary signals like 0 and 1s. So how does computer actually understand and be able to analyze your voice command? For example, like when you say Siri, help me to call my mom, or Siri, help me to check what's the temperature today. So the secret behind all this is, first of all, they use this sort of voice command device, right? They if you try it enough times, you will realize that they are they are sort of repetitive, so they don't really have a context, and they don't really have a memory. So what they usually do is they take whatever you have spoken, and then turn it into text, and then behind the scene, then they use their engine to analyze the content of the text and try to identify what are the actions and what are the what are the criteria, or what are the other information from those actions. And and to be exact, the voice recognition market in 2000 between 2019 and 2015, right, is expected to grow a lot. Yeah. So, and actually, um, in the shadow of COVID-19, right, we should expect to see more voice activated devices or use cases in the market as well to be commercialized, because we try to promote things that are not or not contactless, that sort of activities. So there should be a market as well for using voice activations and to do something for us. But if we just look at the market for example, like Alexa and also HomePod, for example, right? Yeah, the market is pretty huge. And this is what I was mentioned earlier, how it works. So first thing first, when you speak something, okay, when you say something, it will be converted into string by using recognizer or transcribe speech, basically. So then there's a voice bot that helps to interpret your natural language, and then from there it identifies your intentions and look up data and decide how to respond. And that's only the first part, right? And after that, they will need to generate a semantic representation for response. And for example, in this case, they want to check your orders, and then after that you will reply with the status of the order. And in order to make the bot looks more realistic and less robotic, I would say, right? Less artificial. Then they will. There are two things that we need to work on. Number one is the way they speak. So if they always speak in a fixed way, in a fixed manner, then it will look very fake, very robotic. And the second thing, which is the TTS, the text to speech engine. So of course the speech is synthesized using synthesizer. So we there's a lot of research that's put into work to make the TTS sounds more human, basically, right? More realistic. So that those are the key areas. But what we are going to discuss today is actually the voice bot part, yeah, which is the understand or interpret the natural language. So natural language part is handled by this particular technique called natural language processing, or what we call NLP in short. So what is NLP actually? NLP is a subfield in artificial intelligence. So a lot of people have been talking about AI. So NLP actually is a subfield in AI. Yeah, and the reason why NLP is interesting, and of course the reason why NLP is hard, is because NLP itself is a cross-discipline subject. It's not a single subject. So by studying NLP, it requires you to understand a multiple thing. Yeah, not just language, not just, so let's say if we use English as an example, right? You need to understand the grammar of English first of all, and then you need to understand the linguistic and the statistics, and of course the computer science behind it. So it's quite a, I wouldn't say it's hard, yeah, because my background is in NLP, right? But it's something that has a lot of it covers a lot of areas. And example of natural language is English, Chinese, and Malay. So these are natural language. Now among these three language, right, there's something that's very interesting is that when we use language, let's say English or Malay, right? These are alphabets, Latin-based language. So the separators is very obvious. You can easily just split characters, split a word using the gaps between two words, right? Using space. But if you apply it to some language like Chinese, then it will be difficult. I'll explain a bit more in a bit. So typically, apart from using NLP for, let's say, the voice bot like Alexa or Siri, we also use NLP for other tasks. For example, we use it for information retrieval. Yeah, so like Google is a typical use case of NLP. You enter a query, and then you interpret the query and try to find out what are the keywords, and then they retrieve the relevant results from their database and return to you. And the second one is topic detection. So this is very commonly used in areas with large amount of topics, for example news articles, social medias, etc., or even like hotel reviews and comments. So what we usually use NLP for topic detection is to identify what topics people are talking about. For example, in presidential election campaign, we need to find out what the voters care about, and we can, like, whether they care about education, they care about the qualification of the candidate, or they care about what else, education, medical, for example, right? Yeah, then they can we can use topic detection to analyze their social medias like tweets and Facebook to understand what are the things that they care about. And of course we can use it for sentiment analysis as well. So if you run e-commerce stores and your customers always give you feedbacks and comments, and you can look at these feedbacks and comments to try to find out whether they are giving you positive feedback or negative feedback. And this is sentiment analysis. And machine translation, this is the one that is we have made quite some major improvement in the past few years, thanks to deep learning, but there's still a lot of funny cases. This is basically the automated translation using tools like Google Translate. And last but not least, a question answering system. A QA system, question answering system, will be very similar to, say, for example, a chatbot or voice bot that I was showing you earlier. So basically you ask a question and then they retrieve an answer. Alright, so let's dive in to take a look at how NLP works. By the way, if you have any questions, feel free to leave them in the comment section. Alright, so I'll explain to you. I'll answer your questions. And First thing first is tokenization. So tokenization in natural language processing is a process that we want to break an input document into the smallest information unit. So the reason, the motivation behind breaking it down into the smallest information unit is that we need to break them into smallest information unit so that we can process them. Okay, so for example, you have a sentence called "the quick brown fox jumps over the lazy dog," and the easiest way to break them down into smallest information unit is break them down into words, or what we call terms. So it's "the quick brown fox jumps over the lazy dog." Now I have a question for you, right? Let's pause for 10 seconds. Now think about it. Is every single token, meaning the term or the word here, meaningful? Think about it. Okay, maybe not, right? Because when we say meaningful, it has to be it has to be words that help the computers to understand the meaning of the sentence, so that it can return you more meaningful results or more related results. Now, if we look at this sentence, the quick, so quick brown fox. Let's look at the token one by one. The first one doesn't really help you to understand the sentence any better. It doesn't give you any context as well, right? And quick, yes, it describes the speed. Brown, yes, because it describes the subject fox, and of course fox is important because of the subject, and jumps is the action, is a verb, and then over, yes, and maybe in certain cases over is not, and then lazy dog for the same reason. So dog is the predicate, is the object, and lazy is to describe the particular is an adjective to describe the dog. Okay, so next thing what we need to do is we need to remove terms that do not carry any useful meaning, especially those that frequently occur. Now the word frequently occur here, it doesn't mean that it frequently occur in your input document. It refers to those that frequently occur in that language. Okay, so in English we see all those terms like is, mr, the, he, she, it. Those those are stop words because they frequently occur and they do not carry any specific meaning. So in our case, we're going to remove the and over, right? And after we have removed them, our input document looks a lot tighter. Yeah, and quick brown fox jumps lazy dog. And also another thing that you need to remember is text processing. From a mathematical standpoint, text processing is something that is high dimensional. So when you have something that's high dimensional, you have to be careful, because any information that is useless and you put it there will actually increase the complexity of calculation. Yeah, so if you do that, we try to reduce the information inside our feature space so that we can speed up the computation. And the next thing that we need to do after we have gotten our input document, we have to represent them in the form of feature. And the word feature here means, in machine learning, it means some characteristic of that particular input data. Yeah, in our case is the words that we use. In image, it can be the colors, it can be the shapes, it can be the size, and in business data, it can be, like, for example, your customer name, your customer details, and the amount that they shop. So in the eyes of computers, that particular string or the particular sentence that we have given it, right, because computers do not understand text, yeah. So in the eyes of computers, it's just a bag of words. Basically, you just dump every words into a particular bag. Okay, that's how the computers understands that. And after we have done that, right, we have to convert them into a matrix. This particular matrix is to help us to understand the occurrence of a particular word. Okay, is to help us to understand occurrence of a particular words. So for example, you have good movie, and it will be a matrix where good is 1, movie is 1. And that's why I was saying we have to be careful of the word that we choose to put inside the matrix, because if we simply just take any terms and put it inside, right, it will make the uh, it will make the matrix very sparse, as in it contains a lot of zeros. Okay, and this one I have covered already. So yep, so that's it for today's data science clinic. We briefly covered natural language processing, which is the technique behind Google Home, Siri and Alexa. So if you have any questions, feel free to leave them in the comments. So even if you are watching this afterwards, right, if you have any question, just leave your comment below. Leave your question in the comment section below, and I'll answer them. Alright, so if there's no questions, thank you very much, and I'll see you in the next